In this video, we'll talk about multiplying and dividing with scientific notation. So let's jump right in. Start off with an example. So we're multiplying 2.2 times 10 to the 6th times 3.7 times 10 to the 8th. Now, if we really think about this, we can rewrite this as 2.2 times 10 to the 6th times 3.7 times 10 to the 8th. It's all multiplication, therefore it doesn't matter what order I do it in. I can move around some things, and I'm not going to change the product. So I could have 2.2 times 3.7 times 10 to the 6th times 10 to the 8th. Now, the benefit of kind of doing it this way is I can kind of block off what I'm doing. I can deal with the powers of 10. In this case, I'm multiplying like bases. This becomes 10 to the 14th power. And then likewise, I can take 2.2 times 3.7, which if I run off to my calculator, I get 8.14. And that number is already in scientific notation, so we are done at this point. So multiplication is much simpler than doing the addition or subtraction. I do not need the powers to be the same. They can be different. All I'm going to do is, instead of trying to multiply the big numbers, I multiply the tens, and then I multiply the numbers. And then I make adjustments as need be. I may get something that's bigger than 10. In that case, I bump the decimal over, I increase the power, so on and so forth. I just have to adjust it to make it scientific notation. Now, the other way to do this is we could expand both of these numbers out and do the multiplication, but again, it's going to be a very, very long process of doing that. And even if you run your calculator, it's going to spit it back in terms of scientific notation. So in this case, using the scientific notation is very, very useful and helpful over using standard form. So let's go ahead and talk about a division example. So again, the way we have multiplied fractions in the past, we could rewrite this as 1.2 over 1.3 times 10 to the 12th over 10 to the 4th. Because when we multiply fractions, we multiply the top times the top and the bottom times the bottom, like we did here and here. So I've changed nothing by writing it like I've done in red. Now I can use my division rule with powers. Since I have same base, I subtract the powers. This becomes 10 to the 8th. And then I calculate 1.2 divided by 1.3, which if I run to my calculator, I get 0.923076 repeating. And that's okay. We can make that a scientific notation number pretty easily. So, how we go from here, if we estimate, so let's go ahead and just cut it off at the thousands place. We'll do the first three digits. So we have 0.923 times 10 to the 8th. Well, this is not scientific notation. This decimal needs to be over here. So I'm increasing my number, which means my power must decrease. So I moved it one place, so it's a change of 1 for both. So 9.23 times 10 to the 7th power would be an estimate for how, or for our division solution here. Now again, we could expand out both these numbers, do the division, run to a calculator, plug them in, but then we have to make sure we have to plug in the right number of zeros, and there's a lot of problems with that, a lot of opportunity for a mistake. Or we can break it up, we can divide our numbers and divide our powers of 10, and then just put them together at the end and adjust as we need to. So just two ways of doing the same thing again. But in this case, as opposed to addition, subtraction, division and multiplication is actually very, very easy, or I guess simpler, to use scientific notation structure as opposed to standard form structure.